In this video, we're looking at how to sketch linear graphs. Now, for the vast majority of the time, the only really method that you need to use is the intercept-intercept method. Now, you will have learned the gradient intercept method, you might have learned some other methods. The intercept-intercept method is pretty much all you need to sketch a good linear graph. Okay, so we're going to write down just an arbitrary graph, so we're going to try y equals 3x plus 9. And so we launch into our steps. So step 1, we're going to find the y-intercept. Now when the graph is in this nice sort of form where it's y equals, then it's really straightforward. This will be our y-intercept. But let's say y. So to find the y-intercept, we have to think about what's actually going on with the y-intercept. So I'm going to draw it here. And there's my y, there's my x. Now, if I look along my y-axis, if this was the y-intercept here, right, intercept meaning where it cuts, my x value would be 0. If the y-intercept was here, my x value would be 0. If the y-intercept was here, my x value would be 0. So no matter where my intercept is, as long as it cuts the y-axis, at that point the x value is 0. So we can find the y-intercept in general by letting x equals 0, and we're doing this to find the y-intercept. Okay, so letting x equals 0 just means replace x with 0 in the equation. So we end up with y equals 3 times 0 plus 9. You'll excuse my y with its big tail, so let me change that. So 3 times 0 plus 9, which equals 0 plus 9, which equals 9. Now hopefully a lot of you are saying, well, that was obvious, I saw it was 9 from here. Yes, but that's only because we have y on its own for this question. If y wasn't on its own, then this idea that whatever number's on the right hand side is the y-intercept, that idea wouldn't work. So it only works because y is on its own here. Now step 2, we're going to do the same thing, and we're going to use the same logic to say, well, if we have an x-intercept, no matter whether it's here, or here, or here, or here, wherever we might be, the y-intercept will be, the y value will be 0, right? No matter if we're here or here, the y value will be 0. So if we let y equals 0 this time, right, it's always the opposite of the one you want to find, so we're trying to find the x-intercept this time. So then we end up with, well, if we replace y with 0, we end up with 0 equals 3x plus 9. So let's take 9 from both sides. We end up with 3x equals negative 9. And therefore x equals negative 3, right? Just dividing both sides by 3. And so we have our two intercepts. The first intercept is this is this 9. So y equals 9, right? That was the y-intercept. And the second intercept is x equals negative 3. So I'm going to go back to my graph here. I might just draw a new one so it's nice and clear. Okay, so first of all, I rule my axes, okay, making sure they're nice and straight. Now I'm on a computer, so obviously my axes should not be as straight as yours. Hopefully you can do better than me, but I'm going to do my best here. So draw some straight axes, and that's my y value, that's my my y-axis, and that's my x-axis. So all I do is I go, well, y equals 9. I'm going to go ahead and put that somewhere on the y-axis. You don't have to measure, you don't have to rule notches, so you don't have to do, this thing that you might have done in earlier years. All you have to do is put a point on the y-axis somewhere and label the point. That's really important. Okay, so the point is 0 and 9. If you don't label the point, you're going to lose a mark. So as a reminder, we're going to say label the point. Okay, just reminding ourselves of what we need to do. Then we're going to put our x-intercept on the x-axis, so maybe here. Now, again, it doesn't actually matter where you put it. So it's not like if this is 9, that must be 1/3 of 9. The scale on the x-axis and the y-axis does not need to be the same, so they can be different. All right, so you put the 2 dots on, you label the points for each one, right? And then you simply rule a line between the two. So I'm going to go ahead and just rule a line between the two. Now, again, I'm on computer, right? Your line should be straighter than that, but it's a line, straight line that goes through the 2 points that you've labeled, and that's it. We're done. Okay, so that's all you need to do to graph any line. Now, we're going to do one more example just to sort of consolidate the idea. This time, we're going to use an equation that doesn't have y on its own. So let's go to this side. All right, we'll use something nice and ugly. So hopefully it looks a little bit scary the first time, but you'll see that it's very much the same. So we're going to do, 4x minus y equals 7. Okay, and we're asked to sketch that. All right, well, the process is exactly the same. So we're going to start off with our step 1. And remembering our step 1 is just to let, x equals 0, because we want to find the y-axis, okay? So to find the y-axis, it's not what I want to say, we want to find the y-intercept. My apologies for that. So we're trying to find the y-intercept. Remember, that's our goal. Just like we did here, we let x equals 0 to find the y-intercept. So we're going to do the exact same here. Now, note this time, 7 is not the y-intercept, okay, because we don't have y on its own. You could, if you wanted to, rearrange it and get it that way, but I feel like if you do that, you're more prone to a mistake. So all I want you to do is let x equal 0. So you're going to replace the x with a 0, and you end up with 4 times 0 minus y equals 7. Negative y equals 7. And so therefore, if you times both sides by a -1, you end up with y equals -7. And that's your y-intercept. Then we're going to do the same thing. So step 2, we're going to do the same thing, but now we're going to let y equals 0 to find the x-intercept. Okay, so if we replace y with 0, we end up with 4x minus 0 equals 7, so 4x equals 7, and if we divide both sides by 4, we therefore have x equals 7 on 4. Okay, so we have our two intercepts, y equals -7 is an intercept, and x equals 7 on 4 is an intercept. We go ahead and rule our axes. So we've got, let's do that one again. We have 1, and if I stop pressing on the screen, we have 2. Okay, it's not a big deal that they're not even. That's all right. So first step is to put the y equals -7 on there, so it actually works out quite well because we have a larger portion that's negative, so maybe somewhere down here, making sure to label your point. And then we're going to put in the x equals 7 on 4. Now, you might be thinking, well, I don't actually know what 7 divided by 4 is, or I can't estimate that. Okay, honestly, it doesn't matter. You know that it's less than 8 on 4, which is 2. You know that it's more than 4 on 4, which is 1, right? So it'll be somewhere between 2 and 1. But again, the scales on the y-axis and the x-axis don't have to be the same, so you can just plonk it somewhere there. Call it 7 on 4, right? We like improper fractions, and proper fractions are our friend because we're adult mathematicians now. And we're going to go ahead and connect our 2 points with a line going through both. Again, you're not going to have this squiggly bit because you're not on a computer. And that's it. That's all we need to do. Okay, we've shown our 2 points, we've shown the line, we've labeled our axes, we're happy. Okay, so that's all you need to do. That's the intercept-intercept method. Now, there are 2 exceptions. So let me talk very briefly about the two exceptions. So, exception 1. Alright, so the first exception is if you have something like sketch y equals 6. Okay, so if you just have y equal to a number, this is a very simple graph to draw, but it does sort of trip a lot of people up. So I'm going to draw it very quickly. Sketch it rather. And so we have our axes roughly like that. There's our y, there's our x. Now, if y equals 6, that means y is a constant value throughout. So no matter what x equals, so even if x was, 4, y would equal 6. If x was -5, y would equal 6. So no matter where we are on the x-axis, y has to equal 6. So the only way to draw that, or to sketch that, is by drawing a very straight line parallel to the x-axis. So it just stays exactly at y equals 6 all the way through. And usually with a graph like this, we do want to label it. So we're going to label it y equals 6, just to show that, I haven't accidentally put the axis too high or something like that. I don't know, but just makes it a bit clearer. And the second exception that we're going to look at, so exception 2, is if we have something like, so something very similar, let's say x equals -3. So I'm actually going to sketch this on the same axis, so I'll do it over here. Now, if x equals -3, that means no matter where we are on the y-axis, like if we're here, x will be -3. If we're here, x will be -3. If we're here, x will be -3. So much like this case, if it's x equals a number, just a constant, we're going to have a straight line, but this time parallel to the y-axis. So going straight down. Again, note that I have a slight kink in this line. You won't, because you're ruling it on paper, not on a computer. And you just label your intercept. So the intercept here is not 3, it's -3. And that's it. That's all you need to do. So those are the two exceptions. Everything else you can attack using the intercept-intercept method, and that works perfectly well. All right. So everything else, whether it looks like y equals something or something different, if you're asked to sketch, all you need to do is use the intercept-intercept method, with the exception of